Hello everyone, today I'm here to explain some data visualization using Python. This is the dataset I'll be working with. NCC Consolidated, which means National Contract Commission. This is an agency responsible for transparent award of contracts. As you can see, this consists of 13 columns. However, I'm only interested in the date, government agency, fund, contractor, procurement method, and Jamaican equivalent. This dataset consists of 6,092 rows. For the visualization, you need to have Jupyter Notebook installed. You can do this by installing Anaconda from this website and Python from python.org. I'll leave links for these download in the video description. Now, this is my code for my visualization. I'm interested to determine the funding agency on behalf of the contract we're awarded and the features that determine the funding agency. For this reason, I've built a decision tree and a neural network. These are the libraries needed for the visualization. For the visualization, I've used mostly functions to reduce the amount of code. For instance, to import the dataset, I've used import data source and store it in a local variable, National Consolidated Data, or NCC Consolidated Data. And these are the rest of function. I will leave comment to explain the use of these functions. For instance, to drop the unnecessary columns, I use drop columns. Fill in missing data, use to fill in the most frequent data in the missing rows. And create labels for the encoded data and print the encoded labels and transform the data into the encoded values, which I will allow it for processing. Right here, separate the data into the target variable and independent variable. And this function changes the data using entropy, and this one use Gini. This function shows significant features of the dataset that determine the funding agency. This here for the tree visualization for the decision tree, and this predicts the accuracy of the dataset. And this generates a confusion matrix from the dataset. So I'll go ahead and run the code now to see the visualization. So as you can see, I've created a display to reduce the amount of visualization shown on the screen. So as you can see, the length of the dataset and the shape. The dataset itself showing the 5 first rows. This tells what data type we are working with. So far we are working with float, objects, and integer. This shows the amount of data missing from each rows. This also gives a description of the dataset, such as discussed before, the objects, float, and integer, and this shows the amount of memory utilized by the dataset. Now, since the missing data function has run, it has filled in the dataset, so there's no missing data anymore. Another view of the dataset after the columns, unnecessary columns were dropped. Now, as you can see, each column being encoded. These are the regular values and these are the encoded values over here. So for date, you can see 0 to 642, those were encoded, or should I say distinct encoded values. And also you can see government agency, but I skip to the rest of data. And you can see for funding agency, you have government funding and non-government funding. So there's two encoded values, 0 and 1. So another view of the dataset after they have been encoded. Now this gives a summary of the dataset. So far it's showing that in the dataset, date of 643 unit value, and as you can see, these are the rest of unit values. And the top frequency of a specific value in the date is 60, and for governing agency 572. As you can see, there's a difference between the description of object or string value versus float. For the float, you can see you get mathematical values such as means, standard deviation, minimum, and so on. Now, this visualization tells the Jamaican equivalent, which is dollar value per month. So as you can see, July 2001 of the highest contract being awarded. Now, this will give a comparison between university funding and non-university funding. And as you can see, non-university funding get the most funding. Now, this is a 3D visualization to give a visualization to show some correlation between Jamaican equivalent procurement method and funding agency. So as you can see, pavement and paving as the highest dollar value contract being awarded. And it's a government funding. It's funded by GOV. And the procurement method used is, okay, I already explained that, survey and paving. So as you can see, some explanation of some liability importance, but that's not validated right now. And the Jamaican equivalent per day. So as you can see, this clustered of per day contracts. And you can see the government agency, GOJ, fund the most contract there, as you can see by the blue custard, and the highest value contracts. Now, another view of the distribution of number of contracts awarded per quarter. So you can see July 2008 to September 2008 as the highest number of award being awarded, whereas 2002 from April to June have the lowest number of contract being awarded. Okay, similar right here, you can see procurement method, which is survey paving as the highest number of contract being awarded, and these one near the lowest. Now these are funding agency for a number of contract being awarded. As you can see, GOG has the highest number of contract being awarded. Well, these are the lower one, are none in, well, you're not seeing a specific value here. Now, did some filtering to show the most used or the 8 most used constructors. So Alcara construction top use constructor followed by Shuri paving, and the lowest is construction solution and Fujitsu transaction solution being awarded the lowest number of contracts. Now, similar, you can see the procure method and the Shuri and paving highest value procurement. Now we are finished with the initial dataset visualization, so move on to the classification. So I'll go to decision tree first. Okay, for decision tree, this is a splitting of the dataset into the independent variables and dependent variables, and this is how the dataset is split. Now, as you can see, the date and the procure method is the highest significant in determining the funding agency using entropy, and date using Gini. Now you can see the accuracy of the confusion matrix. So there were 1,347 predicted correctly and 481 incorrectly. So for confusion matrix, this is saying that these were predicted true positive and these were predicted true negative, and these were the error in the prediction. And using decision tree gave a 73.69 accuracy. Similar right here using Gini, predicted 1219 correctly, 609 incorrectly, and so on. This is very accurate, so because it has a true positive of 1210 and 7 in it, true negative. Well, that's the error, and this is true positive. Okay, and it's a 60% accuracy using Gini decision tree. Confusion matrix again, while it is being when it was normalized. Now this is just a text expression of the decision tree. Alright, for the decision tree, I look into it. Okay, and this is the output of the decision tree stored as an image. As you can see, as said before, the date as a higher contributing factor, followed by the procure method. Now I'll move on to neural network classification. Similar as I explained before, the independent variables and dependent variables, the splitting of the data set. However, for neural classification, it has 3 layers: the input layer, the hidden layer, and the output layers. Now, this is a prediction for the funding agency. So, 1239 to 589 false. And this is similar as percentage in our pie chart. Confusion matrix also. So true positive, true negative, and the error. Now decision tree accuracy 67.78 using decision tree. Now this is a comparison between the modules. So as you can see, entropy is the highest level of accuracy, followed by Gini, or should I say neural network prediction, and then Gini. So, well, these are the visualizations that were shown before, but I'm not going back into that. So this would conclude my explanation for the code that I've written. However, I leave it on GitHub for access, and I've commented most of the code to explain the usage. So as I was explaining, splitting off the model right here, print the accesses, percentage of the splittage. So I conclude that and add it to GitHub. Thank you for watching.